This is question 5, the June 2015 AQA GCSE Physics Unit 2 question paper. On screen now is a mark scheme for the question, so please mark your work. If you get the question correct, I suggest you move on. If you get the question incorrect, please listen to the rest of the recording to find out how to answer the question correctly in the future. On screen is part A of question 5. I'm going to move the slide on in a moment so you can see part B. This is part B of question 5, the mark scheme for it, so please mark your work for part B. Once you've finished, please listen to the rest of the recording to find out how to answer all parts of the question correctly. In question 5, it says a 12 volt filament bulb is connected to a 12 volt power supply. Figure 6 shows how the current changes after the bulb is switched on. You've got a graph there. It says after 10 seconds the bulb works at normal brightness. What is the current through the bulb when it's working at normal brightness? So we're looking for 10 seconds. You can see around here it's normal brightness. You can see that's 3 small squares lower than 2, where each small square's at 0.1. So the normal brightness is going to be 1.7 amps. I just read that from that line on the graph there. Minusing 0.1 from 2. That's the first mark of this question. The next part of the question is the bulb works at normal brightness for 30 seconds before it's switched off. Calculate the charge that flows through the bulb in 30 seconds before it's switched off and give the unit. Use the correct equation from the physics equation sheet. So in the previous question we kind of got a hint. We found out that the current, which is I, was equal to 1.7 amps. We now want an equation that links current, charge and time. And that equation from the equation sheet is that Q equals I times T. Q is charge, I is current, and T is time. So our charge is going to equal 1.7 multiplied by the 30 seconds. That gives you an answer of 51. So our charge is 51. We now need to include the unit, and the unit is coulombs, or capital C. In terms of marks, you get times 30, 1 mark, getting the correct answer of 51, and then getting coulombs, or capital C, is a third. In the next part of the question, it says calculate the energy transferred by the 12 volt bulb when it's working at normal brightness for 30 seconds. Use the correct equation from the physics equation sheet. So we're given that the voltage is 12 volts. From the previous question that we've got that the charge was equal to 51 coulombs. We now want an equation that has energy transfer, voltage and charge, and we get that one to be voltage is work done, which is basically energy transfer, over charge. So rearranging that to find W, which is work done, we get V times Q, which is going to equal 12 multiplied by 51. That gives us an answer of 612 joules. An alternative method, if you're interested, is to use that energy is power times time. Just ignore that signal. Energy equals power times time, where power equals I times V. So that gives us that energy equals I times V times T. I in the first one was 1.7 multiplied by our 12 multiplied by our 30. And that should give us the same answer. When that into the calculator, it gives you the same answer, which is 612 joules. I personally find the first method more straightforward, but you use the one that makes the most sense to you. In part B of the question, it says between 0.02 seconds and 0.08 seconds, there is an increase in both the resistance and the temperature of the metal filament inside the bulb. Explain in terms of the electrons and the ions inside the filament why both the temperature and resistance increases. So, the idea is as the temperature increases, ions vibrate faster That's your first mark, because they begin to move around more because they've got more energy, so they vibrate faster. And if they're vibrating faster, that means there are more collisions between ions and electrons. And that increases resistance R. And that's the second mark. The idea that there's more collisions. So you got a mark for basically saying more collisions, that's because the ions are vibrating faster. And on the last question, last point, you have to have the idea that it's ions and electrons that are colliding. If you just say electron or just ion, you haven't got enough to get the mark. It's the idea that there's more collisions between the electrons and the ions that are vibrating faster. That brings us to the end of this question.